Okay, let's start with a warm-up, just like we would if you were in class. Okay, so I'm assuming or hoping you paused the video and tried to do this. If not, that's okay too. So 5-letter permutations from the word serendipitous. Well, serendipitous, I love that word. It's one of my favorite words. The movie Serendipity is also a classic. I don't know if anyone's seen it or if I'm too old. So serendipity has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 letters. So we have 13. P, we're choosing 5. Ratio of factorials. So this is 13 factorial over 13 minus 5 factorial, which is 13 factorial over 8 factorial. Okay? So that's writing it as a ratio of factorials. So pay attention to what you're being asked for. Okay, 15p3 is a product of integers. Well, if you're choosing 3, our first choice we have 15. We used 1, now we have 14, now we have 13. So there's our product of integers. Brooke and Paige have 16 princess dresses, and how many ways can they each wear one? Well, Brooke can wear, they have 16 princess dresses total. So let's say Brooke chooses, there's 16 choices, she chooses one, so Paige has 15 to choose from. 16 times 15 is 240. You could have also done this as 16p2, and that would get you the same answer. Okay, 6.6 is conditional probability. So if B equals a person eats a good breakfast, L equals a person eats a good lunch. We have a group of 80 people. You can read this. I'm going to make the table and then we'll talk through where it's coming from. Okay, so let's make an organized table. So basically we have good breakfast, good lunch, not a good lunch, not a good breakfast. So we can make a table. It's not what I wanted to do. I wanted a straight line. Okay, so we have breakfast, no breakfast, lunch, no lunch. That's what we're talking about, good breakfast, not good breakfast, etc. We'll just simplify it. So then, in a group of 80 people total, 43 people eat good breakfasts and good lunches. So that's going to be right here, the intersection of kind of the breakfast and the lunch. 21 eat a good breakfast but not a good lunch. So the intersection of like breakfast and not lunch. So this is 21. 12 eat a good lunch but not a good breakfast. So lunch and not breakfast is 12. And the rest eat neither a good lunch nor a good breakfast. Well, let's add up the columns and rows. So 43 plus 12 is 55. This is 64. Our total's got to be 80. 80 minus 55 is 25. 80 minus 64 is 16. And then we're finding what goes in here. Well, 16 minus 12 is 4. 25 minus 21 is 4. So now find the probability of B and L. So this is like the overlap. So B and L is the intersection of the B and the L, so it's 43 out of our total, which was 80. Probability of L given B, so that given piece is our denominator. So how many people had a good breakfast? 64. Out of those people, how many had a good lunch? 43, because we're looking at only this column now. So 43 out of 64. Find probability of breakfast given lunch. So now our denominator is all the people that had a good lunch, which is 55. Out of those people, how many had a good breakfast? Still 43. So our denominator changes, but we have 43 as our numerator regardless. Okay, an article in the Journal of the American Medical Association in 1997, a while ago, reported that when you go to your doctor's office with a sore throat and think you might have strep, 30% of those people have it. And the test was 80% accurate if you have it and 90% accurate if you don't. And we're looking for what's the probability that a person who receives a positive result does not have the disease. All right, we're going to make a tree diagram. So basically, as far as what's actually true, you'll go into the doctor's office and you either have strep or you don't have strep. I'm going to say strep, no strep. Okay, this is like you're walking in, you have strep or you don't have strep. And then from there, either way, you're going to take a test and it'll be positive or negative. So if you have strep, you take a test, it's positive or it's negative. You don't have strep, you still take a test and it tells you positive or it tells you negative. So now we know that of the people that go in, 30% have strep. So as far as here, this is 0.3, 30%. So that means 70% don't have strep that go in thinking they do. So you're like, oh, I have a sore throat. I think I might have strep. 30% of the people do, 70% don't. A current test was 80% accurate if you have strep throat. So if you have it, accurate means you get a positive test. So then this is 0.8. So 80% says you have it, you get a positive test. This is 0.2, okay? Because that adds up to 1 or 100%. It's 90% accurate if you don't. So if you don't have strep, for a test to be accurate, it should tell you you don't have strep. So 90% of the time, if you don't have strep, the test tells you you don't. 10% of the time, you don't have strep, but it tells you you do. So now from here, we'll multiply through. Just choosing my colors, sorry. So here, strep and a positive test, our probability, we have 0.3 times 0.8, which is 0.24. Strep and negative test, 0.3 times 0.2, which is 0.06. 0.7 times 0.1 equals 0.07. And then 0.7, just following our tree again, times 0.9 is 0.63. And if you add those all up, they do add up to 70%. And 0.24 plus 0.06 adds up to our initial 0.3. 0.07 plus 0.63 adds up to our initial 0.7. Now let's go back to our question that we were being asked. And that was, what's the probability that a person who receives a positive result does not have the disease? So we're looking at all the people who received a positive result. So the people that received a positive result were these people and these people. So that total then is my 0.24 plus 0.07. Okay, so those are all the people that received a positive result. Out of those, who doesn't have the disease? That's the 0.07. So we have 0.07, 0.24 plus 0.07 equals 0.31. So 0.07 over 0.31. Sorry, messing up things in my calculator. This is 0.226, or about 22.6%. Okay, here's some vocabulary. False positive, false negative. So a lot of it is about kind of tests and stuff. So a false positive is when the test says you do have the condition or disease, but you don't have it. False negative is where the test says you don't have the condition, but you do. So suppose all patients are tested for a serious disease that's estimated to be found in 0.5% of people. It accurately spots the disease 98% of the time and accurately indicates no disease 95% of the time. Skip organized table. We're just doing tree diagrams. Okay. So here on the other page we had strep and no strep. Here we have disease, no disease. Okay. So disease, well, okay, let's start here. So given the disease, you take a test and the test either is positive or it's negative. No disease, same thing, positive or negative. That's the good news. These are pretty consistent process to solve these problems. So then the disease is estimated to be found in 0.5% of people. So then disease, keep in mind to change percent to a decimal, you move the decimal 2 to the left or divide by 100. This is 0.005. 1 minus 0.005 is 0.995. So 0.5% of people have the disease, 99.5% of people don't. Given that, the test accurately spots the disease 98% of the time. So if you have it, it says you do 98% of the time. If you have the disease, it says you don't, then 2% of the time, because 1 minus 0.98 is 0.02. It accurately indicates no disease 95% of the time. So if you have no disease, accurate is going to be saying you have no disease or a negative test. So that's 95%. 1 minus 0.95 is 0.05. And now we'll multiply through. So this is, again, we're following just like along the tree. So the D and the plus, so 0.005 times 0.98, this equals 0.0049. 0.005 times 0.02 equals 0.0001. Moving down here, no disease and plus 0.995 times 0.05 equals 0.04975. And finally, no disease and negative test is 0.995 times 0.95, which is 0.94525. Okay. So part B, what's the probability that a person who receives a positive test result has the disease? So we're looking at all the people with the positive test result, which is positive is these guys and these guys. So you either have the disease, and got a positive test, or you don't and you got a positive test. So then our denominator is 0.004975 plus 0.0049. Out of those people, has the disease? Which ones have the disease? Well, that's the 0.0049. So if you simplify this, and if you put this in your calculator, make sure you put parentheses here, you get 0.089, which is about 8.9 or 9%. What's the probability that a negative result is a false negative? So now we're looking at all the negative results. All the negative results are disease and negative result, so 0.0001, plus the negative results where you don't have the disease, which is 0.94525. A false negative is where you actually have it. So we're looking at the negative test where they had the disease, so 0.0001. Again, put parentheses around here. When you put this in your calculator, you get 0.0001. If we change that to a percent, we'll multiply by 100 and move the decimal place 2 to the right. We get 0.01%.